Hey guys, welcome to this session on COVID-19 outbreak prediction using machine learning. In this session, we'll take a look at how we can use machine learning and the data that we have collected so far on COVID-19 to make predictions and data visualizations and use other data science tools. So let's take a look at the agenda. We'll begin by understanding what is COVID-19. We'll then move on to understand how COVID-19 spreads. We'll then take a look at how to prevent the spread of COVID-19. Then we'll understand how is technology helping in the situation. Then we'll take a look at a demo that tells us how data visualization could help us in COVID-19. And then we'll take a look at time series analysis and make some predictions about COVID-19. So what is COVID-19? Well, COVID-19 stands for coronavirus disease. It's an infectious disease that's caused by a new virus, and it started spreading from the China's Wuhan district. This disease causes respiratory illness and something like the flu, and the symptoms include cough, fever, and in most severe cases, difficulty in breathing. So how COVID-19 spreads? Well, COVID-19 is incredibly infectious and it spreads mainly via droplets as a result of coughing and sneezing of a person who is infected by COVID-19. These droplets can spread to other people in two ways. First is direct contact, which is when you're around the person who has contracted the COVID-19 disease, then they release these droplets in the air via coughing or sneezing. Then you end up contracting this disease. On the other hand, there's indirect contact in which you cough and sneeze at some place and the droplets accumulate at some object, and when the person who's healthy comes in contact with that object, they might also end up contracting the disease and the chain continues. So how to prevent the spread of COVID-19? Well, there are many things that you as a citizen could do to prevent the spread of COVID-19. Here are a few of them. The first thing is you can avoid gatherings. So try avoiding gatherings where more than one people gathers around. Try and stay at home. Maintain a safe distance from the other people, at least 1 meters, although it could be more, but at the very least 1 meters. Stay at home because if you stay at home and you don't travel here and there, don't go to gatherings, that's the best option we have as of now. Avoid physical contact because that's one of the most major ways that coronavirus could be spread. And finally, practice good hygiene. Wash your hands, sanitize your hands as much as possible and as often as possible. So how is technology helping in this? So technology is an incredibly important part of our daily lives, and in this testing time of coronavirus lockdown, technology is helping us immensely. There are several technologies that are helping us in many numerous ways. Here are a few of them. So various technological domains are helping us. Let's take a look at them. So the first one is automation. So for those of you who are unaware, automation basically allows us to automate or perform tasks with as less of human interaction as possible. We train a machine, we program some software, some machine, some hardware to do some tasks that a human being could do, and we program it to do it with as less human assistance as possible. Then there's web, as in the internet. Internet is immensely helping us to get through these tough times, as we'll discuss. Then there's data science, which is allowing us to gather the data and make sense of all the data that we have gathered so far, allowing us to extract some key insights from it, visualize the data, take a look at the trends, and understand how coronavirus is spreading and how in places where it hasn't spread, we could stop it. So in places that it hasn't spread that much, what can we learn from the places that it had spread, and what are the things that they did wrong that we could do right? These are the kinds of insights that you could extract from data science. And then comes machine learning that helps us make predictions, help us create models that map onto the real world, that could take in some data and make some prediction about the future, which could also help us to understand whether or not we are winning the fight against coronavirus. Are we flattening the curve? Is the current number of patients that we've encountered on some particular day lower than the number of patients that should have been encountered? And that's how we figure out whether or not our methodologies, these rules that we have imposed, the laws that we have imposed, are working or not, or are they just simply not working? And if not, then what are the kind of things that we can do in order to make sure that coronavirus doesn't spread? How do we need to tackle these issues is what it means. So let's take a look at these technologies one by one and see how they're impacting our daily lives and what are the kind of domains that these technologies are impacting. First comes automation. So automation is allowing companies to perform some really critical tasks. Well, tasks with as less human interaction as possible. So to give you an example, let's say that you have some task on performing. You have some tasks such as whenever you start a system, you need to clear the cache files. Now this is a very trivial example that I'm giving. This is not that important, but if you understand this, you can understand how automation could help you. Now this is a task that contains the same steps every time, just the input might be a bit different, that being the folder in which the cache files are stored. but almost exactly the same thing is happening. You're opening the folder, removing everything in those folders, and you're doing that. So tasks like these could be automated. So there are many tasks that could be automated. Robotic process automation, RPA, is also one thing that could allow you to create these automations. Many industries are using these automations. Let's take a look at them. So e-commerce sites are using these automations to help keep running their infrastructure. They are providing service. Many e-commerce sites are still providing services even with all their employees at either opting for work from home or are not working currently. So even after immense pressure on the workforce, the e-commerce sites are still able to run, and that is because many of the tasks that are critical or mission critical, that without which an e-commerce site cannot function, have been automated. So they are being performed by the machines themselves, and human interaction is not really needed there, or very less human interaction is needed, which could be provided even if in these tough times. And then there's the information technology. So the IT departments of many companies have automated their infrastructure building. So they have written scripts, they have created files that could be read, and the infrastructure on and scaling of the entire IT infrastructure could be taken care of by automation. So something like if you have a website, or to give you an example, an e-commerce site, or you can take an example of any site such as a payment site, and or you could take an example of a video streaming site. Since everyone is at home, the amounts of people looking or using these video streaming sites have drastically increased, and even though the workers are not present because they are also practicing work from home, these video streaming products still keep working the way we expect them to. This is because their IT infrastructure has been automated. So if there's a spike in user requests, the amounts of servers that we have, the load balancers, the infrastructural components that are helping us run these applications, they automatically scale up. Their new servers are created and new applications are deployed on those servers to handle the incoming traffic, and new load balancers are created so that they could distribute the traffic effectively. So this is how it's helping in the IT infrastructure department. And finally, in the maintenance. So many sites, they require monthly, weekly, or daily maintenance. You need to clear the log files. You need to read the log files and extract some information out of it. You need to make sure that the servers are not being hacked, or no unauthorized requests are being sent to the servers, or even if unauthorized requests are being sent to the servers, they are being handled appropriately. And there are many other tasks such as maintenance in hospitals or the hospital infrastructures, and many other departments like banking and all. They require maintenance as well. When we talk about maintenance, what we're talking about stuff that could potentially break, and we take a look at that and understand whether or not it has the potential of breaking or not. To give you a really quick example, let's say that we are maintaining a website that's mission critical to some business, and that website is having a lot of requests being sent to it. Now, usually what a person would have to do is he or she would have to maintain the server, and would have to create a system in which he will be notified that the server is under immense load and it could crack, and then more servers are spun up and deployed so as to reduce the cost. Now, this could be automated just by taking a look at the server's load and figuring out whether or not the server could handle it. And if not, new servers are deployed, new services are deployed for the server to consume, so on and so forth. Then there's web, also called the internet. So web is allowing us to stay connected and keep up to date with the latest news and the services provided. And the internet has simplified many things for us that has helped us get through these trying times. Let's take a look at them. The first is payments. So online payments have gotten a massive boost because of coronavirus. People can't gather around some places. It's unhygienic or unsafe for people to go to places, open doors, touch machines, touch buttons that could potentially be used by other people. So online payments have helped us through that, to combat at least that part of the issue. Even the many government officials have made a push for people to use online payments when and where they can, at least during the coronavirus lockdown. So the payments that you are making, whether it's using the UPI interface, that is applications like Google Pay, Paytm, Phone Pay and all, or you're using your bank's infrastructure using their own internet banking services, or you're using the cards or debit cards or credit cards, all of these payments have been provided to you or have been provided to you to interface with using the internet or the web. Then there's the news. So many news sites are operating, and they are giving you exact up-to-date information about the number of coronavirus patients that are out there, the number of deaths, where those deaths occurred, and how many number of people have risen from which time. Many websites are out there that are collecting the data on a minute by minute basis, and they are displaying the data to us to take a look at the data and then figure out how the coronavirus is spreading, whether the curve is flattening or not. And many different news outlets have made it possible for us to subscribe to them and keep up to date to specific kinds of information. So if you want to take a look at coronavirus, we would just subscribe to the coronavirus news channels, and they'll help us keep up to date on those topics only. And then there's information. So information about coronavirus spreading, information about lockdowns, information about the procedures, information about how and when the lockdown will be lifted, and how things are, how rules are being implemented, what are the rules that a person needs to follow in order to prevent the spread of coronavirus, so on and so forth. Now these are the kind of things that you could take a look on the internet and figure out how you're going to do it. It's very easy and it's very important to understand, mainly because these are the kind of things that help us steer ourselves in the right direction and make the right decisions. Instead of going out, we choose to stay in, because that's the kind of information that has been provided to us by the government of our country, so on and so forth. Then comes data science. So data science is helping us explain and understand the data which has been gathered so far. So several industries are gathering data on a regular basis, and on coronavirus many people are spreading awareness and gathering data and contributing data, but that data is going to be useless to us unless we could in some way gather some insights out of it. We could somehow make sense of the data that we have. If we have 7,000 records of patients who have coronavirus, but we don't know anything about the data, we can't just take a look at the data and understand any insight out of it, then it's basically just history that's helping us keep track of how many people were infected. It does not allow us to make any useful decisions based on that. So this is where data science comes in. Let's take a look at it. So data science allows us to make visualizations. Visualizations allow us to take a look at trends. It helps us understand the trend of how coronavirus is spreading, whether the amounts of patients that are being confirmed every day of having coronavirus, or the potential infected patients. Is it rising? Is it rising more than it had previously? And so on and so forth. Visualizations help us make sense of the data pretty easily. We could just take a look at the data and understand that that's how that works. We can take a look at some graph and understand that the trend is settling down, or whether it's speeding up, whether the curve is flattening, or whether it's getting more sharp. And if it's getting sharp, then what could be the reason, and what is the time period during which the sharpness has increased, and so on and so forth. Then there's analysis. So analysis of data also allows us to gain some important understanding from the data. So if we take a look at the data, we can take a look at how the curve is spreading, how the curve is sharpening, how it's spreading across the entire world, and how it's how spread in one country is different from the spread in other countries, and what is the date from which the spread has gotten more rapid, and what were the events that had taken place on those days, and did those events contribute to the spreading of coronavirus, so on and so forth. Now these are the kind of things that when you take a look at them, you can understand pretty easily, and analysis is very important for us in that. Only when we analyze the data can we extract information out of raw data that we had collected. Then there's insights. Insights are the inferences, the decisions, or the conclusions that we draw from analyzing and visualizing the data. So insights allow us to take a look at the data and say pretty conclusively how the coronavirus is spreading, whether the rate of spread has been decreased, is it increasing, and how much has it increased from the previous days and from previous to previous days, so on and so forth. So as we can see that it's very important for us to take a look at anything like that. So let's take a look at the demo and understand how data science is helping us through that. So I have created a Jupyter notebook for you using the coronavirus data that the government has provided, and so on and so forth. We'll take a look at that, and I will run each cell one by one and explain what's going on. So let me just run this. So the first thing we're doing is we're taking a look at the data, and when we take a look at the data, as you can see that we have these columns called province and state, region and country, latitude, longitude, date, confirmed deaths and recovered. So confirmed means the number of confirmed patients that have coronavirus, number of confirmed deaths, how many people have died because of coronavirus, and how many people have recovered. Now this is for the entire world. So as you can see, Afghanistan, Albania, Algeria, so on and so forth. These are sorted based on their country name. And one thing that you need to understand is that these things are incredibly important for us to understand how coronavirus is spreading across the world. We'll take a look at them. Now we have imported the data and we have passed the dates. So we've told it the date column contains date. So whenever I want to perform some information or some operation on this, make sure that you're performing a date time operation. So to make it easy for me to use, I'll just rename it to just rename some of the columns. So from capitalized D to small d, so on and so forth. As you can see, these are the things that I've renamed. And one thing that I've done is I've done it in place. So instead of me having to reassign a data frame or create a new data frame to use up more memory, I'll do it in place. Now I will create a new column that is named active, and it will confirm the confirmed cases minus the number of deaths minus the people who have recovered. So if there are 10 cases that are confirmed, out of which two of them are dead and two of them have recovered, there are 6 active cases as of now. We'll take a look at that as well. Now let's first take a look at top countries. So the countries that have the most number of active, confirmed, and all of those kinds of statistics. So the countries with the most number of active cases, we'll take a look at them. We'll just run that, and let me just go up. So these are the countries, and we have taken a look at that. These are the countries, and the confirmed number of cases have already been added, and we have gotten the entire country's data. So for instance, we have grouped by country. So if there are 2 columns with the same country, their data has been grouped and then summed together. If there were 2 columns with Afghanistan, then their columns have been added. So 60 plus 70 or 60 plus 50 have been added and all that. Now we've taken a look at, we have created a data frame out of that called world. In that we are taking a look at the worldwide data, and now let's graph it. So we'll use some visualization tools. Here we are using Plotly, Plotly. It's an incredibly popular and incredibly powerful tool. So this helps us to take a look at the data and figure out which countries have been more drastically affected by coronavirus. So this is the code. You can take a look at this. Code is not really important. What's important here is we understand the insights that we're making. So we pass in the world data set that we had created. We're passing the locations that we want to make sure that how many of them are being shown. Then we are passing the location mode. We're passing the color and hover name and all of that. And since I told you that this is an incredibly powerful tool, this is not just some image. I could hover over the images and can figure out what is the number of active cases in each of these countries. The color inside the boundaries of the country is based on how many active cases that country has. So as you can see, the countries with low number of active cases have really light color. On the other hand, countries or places with really high number of active cases have really sharp and dark color. And I could zoom in and zoom out as well. So now that we have done that, let us first take a look at the trend of how coronavirus is spread. So we keep saying that it's incredibly infectious and it spreads really rapidly. So let's take a look at how we're doing that. Firstly, we're creating a figure. Then we're setting the X ticks and the Y ticks. And we're setting up the graph with all the information that we could possibly need to understand what the graph is implicating. Then we group the data by the date, so as to figure out how many cases occurred on a particular date. And then we plot it. So let's see. And this is a plot of worldwide confirmed cases. The dates are not really important here, although you could take a look at the dates down here. What's important is when you see the trend, as you can see that the number of cases weren't that much when it began, and it slowly increased, as you can see where my mouse is going. Then there was a little bit of a sudden increase, but not too much. And then in the last few days, the rise has become incredibly rapidly. So if it was following the trend that it is following now, it would go slowly here, but unfortunately it spread really rapidly, and the number of cases on each day were almost exponentially increasing. So as you can see from here to here to here to here, it's really sharp increase. So this is why it's incredibly infectious. This is why the lockdown is necessary. This is why all the proper hygiene and everything is necessary here, mainly because we don't want to be implicated. We don't want to be infected because of this. Now let's take a look at the top active cases. We'll try and visualize the countries with the most number of active cases. I'll just use pandas. Pandas is incredibly powerful here. So we're taking a look at, we're grouping the data by countries. Then we take a look at the active cases, we sum them up, and then we sort them so as to get the number with country with the highest number of cases on top, and then it starts decreasing from there. This is why we pass ascending as false. Then we take head to be 20. Head 20 basically means give me the top 20 records from the beginning of the data frame, and we reset the index. Now that that is done, we will try and visualize this, and this is what the visualization looks like. So the number of active cases are here, the country name is here, total number of cases are here. As you can see, US has the most number of active cases. This is based on the data we have as of now. The data could be a bit old because I've gotten from Kaggle and other sources, so it might not be up to date to the current dates, but as you can see that these things are being implemented properly, and we have US followed by Italy, followed by Spain, Germany, France, Iran. So these are the top countries that have the most number of active cases. Active cases in the sense people that have the most number of patients with coronavirus. These are the countries. Now let's take a look at the top death rates. So doing the same thing that we did previously, but this time we are just summing up the deaths column. And now let's plot it. So when we plot this is the top 20 countries having most deaths. As you can see, Italy is the country that has the most number of deaths, although US is the country that has the most number of active cases. Then there's Spain, China, Iran, France, and US. And this is why the death toll on Italy was so long, so brutal, because as you can see that there are around 10,000 or 11,000 people who have died as of now in Italy because of coronavirus. And now finally we'll take a look at how many people had recovered. So let's just create the data frame. Now that that is done, I'll just, yeah, so this is what it looks like. So the most number of people who have recovered is in China. This is mainly because it started spreading from China, so they had a lot of time to isolate people, to get them to hospitals, to get them to treatments that could help them recover. So it's around 75,582 people that have recovered in China. And then there's Spain, then there's Italy, and then there's Iran, and so on and so forth. So the most number of people who have recovered belong in China. So these kinds of visualization allow us to take a look at the data that we have and figure out which countries have been more impacted and in what cases. The active number of cases, US is at the top. In recovered, China is at the top, and in the number of cases where people have died the most, then that's Italy. Now let's create a few data frames for us. I'll create a few. China will contain every record that occurs in China. Then there's US, Italy, and India. I've created 4 data frames. All of them contain records only for the countries which they are named after. And now I'll try to plot the confirmed number of cases in all of them to compare them and contrast them. So it's running. It's done. As you can see, I'll show you. The color for China is red. For US, it's green. For Italy, it's blue. And for India, it's yellow. So as you can see, in the number of confirmed cases in China, they shot up rapidly during this time, and then they started to decrease suddenly, because I think this is around the time when they had imposed lockdowns and put all the restrictions that they could. Then the green bar is for US. As you can see, earlier they did not have that many people with diseases, so the increase was not that rapid. Then we moved on, and now the increase has become incredibly rampant. And as you can see that the increase it was incredibly sharp, and it's overtaken all the countries. So that's what that was. Then Italy, as you can see that again it wasn't that bad, but again the number of confirmed cases rose up pretty quickly. And here, as you can see, the increase is now starting to slow down. So as you can see, the increase is not that much now. It's still a lot of number of people that have been confirmed, but still it's not that much. And in India, as you can see, the increase is a bit there, but it's nowhere close to what US, China, and Italy US, China, and Italy, the other countries that we're comparing, has. So that works. Now let's take a look at a similar graph that takes a look at the number of deaths. Okay, so as you can see, this is the number of deaths, and as we had already visualized before, Italy is really at the top here. Other countries like China, they were able to impose the laws and all, and you were able to perform these kind of tasks pretty easily. Then what happened was, and you can take a look at India as well, and you can see that this is working properly. Alright guys, so now that we have taken a look at how data science is helping us and what are the kind of things the data science can help us with, let's take a look at a demo and understand and put the thoughts that we have expressed into practice. So let me just open a demonstration. I've taken the liberty of downloading the data sets from the website called Kaggle and the Indian Ministry of Health and Human Resource Management. So I have downloaded the data sets on coronavirus from there. I have imported a lot of packages and we'll go through with them how to use them one by one. So the first thing I'm doing is I'm importing the data that I want. I'm importing it and converting it into a data frame using pandas. So I do that and I take a look at the first 5 records. So I'm running this. It is going to take a bit of time because all the packages that I have created takes a bit of time to load, and these are the packages and these are the data frame this is the data frame, and it looks like this. We have countries, we have the longitude and longitude, latitude and longitude of the countries, we have the dates, we have the confirmed cases, deaths and recovered. So these are the number of confirmed cases, these are the number of people who have died, and these are the number of recovered cases based on the country. I'll rename some of the names, but because as you can see that these names are a bit long and a bit difficult to type. So for future references, I'll just rename them a few. These are the names that they have currently. This is what they will be renamed to, and I want to do it in place. So instead of creating a new data frame that has the renamed columns, I want to rename them in place. So this is done. Now I would also create another column called active that would contain the number of confirmed cases and the number of deaths and the number of recovered patients is removed from that. So let's say that there are 10 confirmed cases, out of which 2 of them have died and 2 of them have recovered. So 4 of them have been either cured or killed, and only 6 of them are active as of now. So that's the column. And then let's just take a look at the data across the world. So I've created a data frame called top, and I've created a data frame called world. In top, what I'm doing is I'm just taking a look at the dates and all that, and in the world what I'm doing is I'm taking the top data frame that I've created, I'm grouping them by the country, and then I'm extracting the confirmed, active and deaths from those from the data frame. So the data frame is created. Now let me just create a visualization. This will be our first visualization in this notebook. So this is what it looks like, and this visualization is done using the Plotly library, Plotly. Plotly. This is a very sophisticated library, allows us to create really interactive components and interactive graphs and charts and visualizations. So we use this command, we pass in the world data frame that we had created. We want it to be sorted, we want it to be visualized using the location. We want to the range of the color should range from 1 to 1000, so on and so forth. We're defining the scale and all, and this is what it looks like. As you can see, the countries that have the highest number of cases are extremely dark in color, really bright red and really all that, and really light colors are for those countries that haven't been affected that much by this. So as you can see, these are the places that haven't been affected that much, these light colored ones, especially in Africa side. On the other hand, India is highly affected, but other countries like China and all have been greatly affected by this. So as you can see, these are really brightly red. So this allows us to take a look at how the impact of coronavirus has been across the world in different countries. Now when we move along, we create a new figure, and what we do is we try to plot the trend of how the coronavirus spread has spread across the world. So I'll just do that. Okay, so this is what it does. I'm using Seaborn here to create a point plot. A point plot is basically a line graph with some points on it that tells us the date on which these rise has occurred. And we are taking a look at the dates and the total number of cases, and all we're doing is we are plotting them. So this is across the world. So as you can see, the title says worldwide confirmed cases over time. All we're doing is we are just taking a look at this, and now as you can see, the trend was at least in its early stages was slightly increasing. Slowly it started increasing a bit more gradually than it used to, and then when we come here, the change or the rate of increase has taken a sharp turn and it started increasing rapidly. As you can see, that you can also plot the distance between these 2 points, and you can understand how sharp the rise has been. So as you can see, in the later stages, the sharp increase has somewhat stabilized, but it's still a really terrifying statistic to take a look at how rapidly the disease has spread. And the majority of the spread has been in the last 20% of the dates that we have, or the data points that we have. So now let's take a look at the countries that have the most number of active cases. Again, pandas makes it really easy for us. We'll just group the data by country and we get the active number of cases, sum them, sort them in descending order so that we get the most number of active cases at top, and then we plot them. So when we plot them, as you can see, US has the most number of active cases. It's around 1,35,754 cases. This data set may not be as accurate as we would like it to be, because it could be that the new cases have arrived today or they had tomorrow and the data set has been downloaded and being used a few days before that. So as you can see that this is the data that we have. Italy has really second largest number of active cases as of now, and as you can see, it's around 74,000. Then there's Spain, Germany, France, so on and so forth. Now let's take a look at the number of the countries with the highest number of death rates because of coronavirus. So again, we do the same thing that we had done earlier. We group the data frame by countries. We extract the column that contains the deaths. We sum the columns up, and then we sort them based ascending order based on the country, and then we reset the index and we get the first 20 values, and then we plot the first 20 values. So the most number of deaths it has happened in Italy. Even though US has the most number of active cases, Italy doesn't have the most number, still has the most number of deaths recorded. As you can see, there are around 11,000 deaths in Italy as of now. And other countries also have really high number of deaths like Spain, China, Iran, France, US, so on and so forth. So as you can see, coronavirus has affected a lot of places, and a lot of people have faced terrible consequences because of that. Then let's do the same thing for the recovered number of cases and see which country has the highest number of patients who have recovered. And unsurprisingly, it's China, because that's the place where coronavirus started spreading first. So they had the opportunity to react and combat that disease head on and firstly, and they implemented a lot of measures. Some of them worked, and as you can see, they have around 75,000 or 76,000 rather people who have recovered from coronavirus cases. Then following is Spain, Italy, Iran, and so on and so forth. So these are the top 20 countries. Now let's create data frames. These data frames will have the data from these data frames will contain the records of patients from one country that we have specified. So the first one will be for China, then we'll have for US, Italy, and India. Now let's just plot the number of cases, or the number of confirmed cases in all these 4 countries, and see how they have progressed as the time has passed in these countries. So to differentiate them, we have color coded them. China is red colored, US is green, Italy is blue, and India is yellow. So as you can see, China had a really rapid increase in the number of confirmed cases, but then they have been able to sort of put a cap on that. And now they have been able to keep the number of confirmed cases to a bit of sustained level. On the other hand, in US, the things were steady at first, but then they really shot up. Now, if you really want to get into it, you can take a look into the dates in which the disease started shooting up. You can understand how this happened. You can coincide that data with other kinds of data like people coming in, people coming out of the country, with lockdown being imposed, not being imposed, so on and so forth. Similarly, when you take a look at a country like Italy, I think it's the blue country. Yeah, it's the blue one. The blue line represents Italy. As you can see, that is also working really. That also had a really sharp increase in the number of cases, and as you can see, the increase has been gradually rising more and more. Now let's take a look at India. India, compared to other countries, the cases are not that severe because the number of cases aren't that big. This is mainly because of the lockdown and all the proper procedures and all the proper laws that have been put into place. So that has helped immensely. And if this continues and if we keep putting a cap on that, then that could mean that we won't be that greatly affected by that. Now let's take a look at the number of cases of deaths across the world. So it's calculating, and as you can see, as we had already seen, Italy had the most number of deaths. So as you can see, the blue line, which is of Italy, it's way over other lines. So these are the line. This is the country that had the most number of deaths because of coronavirus. China had a lot of cases for deaths of coronavirus, but what they have done is they have been able to use their infrastructure and all that to be to put a stop on that and implement lockdown and quarantine and all that to help prevent deaths. The data for US, I don't think it's that accurate because we have only got the data till the 32nd day of the coronavirus spread and so on. So the data is incomplete, but as you can see, the data had a sharp rise here. So we understand that it's increasing rapidly in US as well. And in India, as you can see, the number of deaths are there, but they are not as stark as the US, Italy, or China. So thankfully, the lockdown has worked there as well. Then there's the number of recovered cases. We run that, and it's running. And these are the number of patients who have recovered. So as we already saw, China had the most number of patients who have recovered, and this is just plotted it them along the day. So the number of patients who had recovered also increased rapidly. Same happened with the Italy cases. Same happened with the US. Also, the US days, the data is not that complete. And in India also, the patients are recovering, but since there are not a lot of patients who have uh, contracted the disease, or at least not as many as there are in other countries like US and China, then that's because of that our graph doesn't show that rapid of a spike or that sharp of a spike. But as you can see, the number of patients who have recovered from the coronavirus cases is still low because of the number of patients being infected being low. So it's not something that's extremely scary. So now let's take a look at what's next. So now that we have taken the look at demo using data science, let's take a look at machine learning and how that helps us. So machine learning is helping us to use the data which has been gathered, and we use it to create a model that maps onto the real world and helps us make predictions. It helps us make classifications. It helps us do time series analysis as well. So let's take a look at this. We can perform regressions. Regressions are basically predictions of continuous values like stock market prices or the prices of a house based on its square footage of area and its locality, so on and so forth. Then there's classification, which basically allows us to classify one image as either one thing or the other thing. It could be that we classify the image as as an image having a tree or not having a tree, an image having a person's face or not having a person's face, so on and so forth. And then there's time series analysis. It's mainly used because time series analysis allow us to take a look at the trend and then make some forecasts. So if we have some data based on the number of dates and all that, then we could make a projection based on the data, based on the trend that it has shown us, and based on that data we make projections for the next few days and figure out how does that map to reality. So now let's take a look at a demo using machine learning as we did for data science. So I have also created another notebook which contains all the information that you might need. Again, I will just import these things and then show them one by one. So the data that we have imported is this. We have the names of the union territories, the names of the states, and all that. This is what it looks like, the number of patients who have been cured, who have patients who have died. One thing that you can notice here is that the number of patients there who had confirmed to have coronavirus in each of these states and union territories have been stored in different columns based on whether they were foreign nationals or the Indian national citizens. So I'll just create a number of total cases that are present in India based on that. So I'll just create another column named total cases that contains the number of cases confirmed for Indian nationals, and we add the number of cases confirmed for the foreign nationals as well. I run this and I find out I read the CSV Excel file that contains all the data, and we are parsing the dates, and what we're doing is we are just getting the data based on the per day data on the countries of India, Italy, Korea, and Wuhan. So these are the regions that have their own Excel sheets inside the Excel data that we have. I've run this. Now to extract the data from that. Now it's loaded up in memory, and I'll just try and visualize the number of patients or the highest number of patients in India. As you can see, Kerala has the highest number of patients. It's 105, followed closely by Maharashtra that has 99 patients. Then there's Karnataka. It's around one third of what Maharashtra has, but it's still quite more. It's 37. And we could keep going down. As we can see, there are some places with only one or few cases. So this allows us to make sure that we understand where the problem is, where the majority number of patients are. And now let's plot the number of patients that have contracted the disease and how many of them have recovered. So what's the let's plot the number of recovery here. So we've run this. This is what it looks like. As you can see, we have also have a legend that shows us the total number of patients and the number of patients who have been cured. So the green bar represents the number of patients who have been cured, and as you can see, the green bar is not that much in Kerala because it has the highest number of patients and recovery takes time. Not that much in Maharashtra as well. Karnataka, there are a few people who have recovered. Uttar Pradesh, there are a lot of people who have recovered, so on and so forth. So as you can see that this allows us to quickly visualize some data, and this would have been very difficult for us to visualize or understood ourselves. Now let's take a look at the coronavirus trends, and we'll take a look at India. So how the rise has happened. As you can see, these are the dates that coronavirus cases have been plotted on, and we are using Plotly. So it's a very interactive graph platform as well. If I want to zoom into some place, I could just select that as well. But right now I want to take a look at it entirely. So we take a look at it, and we can see from March 1st the number of patients start rising, and as you can see the number of patients rising has been incredibly rapid. As you can see that it's exponential growth. It's shown incredible increase in an everyday aspect. And as you can see, after 22nd of March and all that, the trend does start to seem to slow down a bit, but it's still a lot of number of patients, and really in a short amount of time. So in just 22 days, the number of patients have gotten really big. And this is a bar graph that allows us to take a look at the number of coronavirus cases on a daily basis. So how many patients did we get on a daily basis? That was a cumulative graph that allows us to take a look at number of patients that we had on that day plus all the patients that we had previous days, and this tells us which day contributed how many number of patients. So as you can see, number of patients still before March 1st weren't very much. Between March 1st and March 8th, there were a few. And as you can see, the graph does seem to report more cases in some instances and less in some, but the general trend is that it's increasing exponentially. As you can see, it's increasing rapidly, and after March 22nd, the number of patients start to decrease a bit. So we have 24 patients, then we have 25, and on March 25 we have a few patients, and that seems to be the trend here. Now let's just let's perform some data analysis and get the data here. Let's take a look at the death data frame for the deaths of the patients, and this is what it looks like. This is a time series based data. It has dates. These are the dates and how many people died in what country and what's the longitude and longitude of the place. Now let's just extract the only the useful information out of it that we want, and we have sorted it by countries, and we have gotten the confirmed deaths and the recovered number of patients. Now let's create a data frame for India where we get data only from the country India. Then we group them by date, and we get the confirmed deaths and recovered patients only. We sum up the results and we move ahead. And we also extract the confirmed deaths and recovered into separate data frames so as to perform time series analysis on them later on. So that is done. And this is what the group by clause looks like. What it does is it takes some data, groups them based on the date column, and then sums that up, and we are looking at the first 5 records. we have let's take a look at the confirmed deaths and recovered patients across the world. So we just take a look, extract them into their own data frames, and let's just plot them. This is, by the way, across the world. So the novel coronavirus disease 2019 cases worldwide. This is what it looks like. So the number of confirmed cases, as you can see, had a really rapid increase during the last few dates. Then there are number of recovered cases, that's also showing a steady increase. And as you can see, the number of deaths, we have been able to sort of put a cap on that. So the number of confirmed patients are more than the number of deaths, which is a good sign. Now let's make some time series predictions. We'll be using a library called FB Prophet. So Prophet is a library that's been created by Facebook. It's written in Python, and it allows us to make time series analysis and perform time series analysis and make some predictions based on the data that we have accumulated over the days. So we import it. What we do is we get the confirmed cases, we get the deaths, we get the recovered cases, all in one. This is the worldwide cases. Now the way Prophet works is that it needs two columns. One is DS, which stands for date stamp, and the other one is Y, which is the thing that it's trying to predict. So we change the column names in our confirmed data frame, and we convert the DS or the date column, the data inside it needs to be converted to date time. So we do it using pandas. We run that. Then we create a model. We want the confidence interval to be 95%. So we want it to be around 95% accuracy. We create or fit the confirmed model that we had just created. And after doing that, the confirmed data frame has been fitted into the model that we have created. Then we make future predictions for the next 7 days, and we take a look at the last 7 days. So it's running, and the last 7 days that we will have, we had data till 23rd, and you had 7 more days to that. It's 30th of March. So it's making predictions for the next 7 days. And now that that is done, let's take a look at what the data of the prediction looks like. So it's running, and we'll take a look at, we're making the predictions for the future. This is the forecast. We're taking a look at the last 5 records. This is what it looks like. And we had y hat lower, y hat upper. This is the upper limit of our prediction. This is the lower limit of our prediction. This is the prediction that we have made, and this is the date that we have made the prediction for. It's easier to see this, but to make more sense of what it is, we'll just visualize it. And as you can see, that there have been a steady rise in the number of patients. So the prediction is made on that. Also make sure that this prediction may not be 100% accurate, mainly because the data that we have may not consider additional steps that have been taken by various governments across the world, like lockdown, quarantine, sanitization, other kinds of helps that are being provided. So make sure you understand that. And this is the prediction. This prediction is based on the data that we have. Now that's good and all, but let's take a look at some of the components that we are given. So these are the last few days to 26 January 29, and we see the trend that this data has shown us, including the prediction that we have made. And as you can see, it shows a rise in the number of cases, which is to be expected, because after the lockdown, the people who had been infected previously are going to come out, and we're going to have more number of cases. And as you can see, the number of cases do on a weekly basis drop on Tuesday and are incredibly high on a Sunday, and keep rising from Wednesday till Saturday, and then on Sunday they are at the peak. From there they start decreasing. So this could mainly be because on Sundays people are free, so they go to the hospitals and they get themselves screened, get themselves tested, and we get to know more patients around the weekends. On weekdays people are really busy, so they try and skip the office, try not to skip the offices and all, and don't go to the hospitals, and that's why the graph looks like this. So at least the graph that we have created, it maps onto the reality. Now let's do the same thing that we had done earlier, but we'll be doing it for the number of deaths across the world. So we extract the data, we change the column names, we create a model. These are the number of deaths. Then we create a forecast and we take a look at it. So it takes a bit of time because it's a really complicated procedure to do that. And let's visualize this. This is what it looks like. Our visualization, again, it shows that there's going to be a good number of increase. And as you can see that we had created a data for the number of deaths. So as you can see, the number of increase in the number of deaths has been steady, and that's why our forecast looks like this, because the last few days the death rate has been increasing really fast. So this is what it looks like. Now let's take a look at the components of our graph to understand the trend and the weekly data. So as you can see, this is the trend. As you can see, after a while, in the last few days, the number of deaths have been dramatically large. And again, it's mapping on to the same thing that we had done earlier. The number of deaths have been larger on Saturdays and Sundays, and then the data that we have is mapping onto reality as well. Now let's take a look at number of patients who have recovered. So we're performing the same steps. It's churning away the data and figuring out the model. Okay, so we have made the prediction. Now we are forecasting it into the future. It's done. Now we take a look at it, and as you can see, the number of recovery is also going to take a rapid spike as more number of patients get introduced. The number of patients who have recovered is also going to increase, and there's a good amount of people who are getting recovered because of the healthcare efforts. So that looks good. Now let's take a look at the weekly components. Here it looks like the number of patients who have recovered matches with the number of patients who have active number of cases. So when the number of people who had who were active in having coronavirus increased, the number of recovery also started to pick up, because you can't recover from a disease that you don't have. After that, we take a look at the weekly estimates. So again, it's mapping onto some of the things that we understand, and this is what it looks like. Now we'll do it for India. So this was done for the data set that we had for across the world. From that, we have extracted the data only for India, and we'll do the same thing here. So it's we have renamed the columns, we have created the model, we have fitted the model, we have made the future predictions, and let's see, we are forecasting it. As you can see, it's running still. These are the forecasts. Now let's just run this. So again, the number of cases that we have are not that much, so it's not really that big of a deal. Plus, the data might not be that accurate. But as you can see, the number of patients are increasing, but the increase is not that sharp. So some of the efforts that have been made by the government have worked, at least in the data set it shows. And since the coronavirus cases haven't been coming to India in that rapidly, or that while back, we can see that there's a really steady rise in the number of patients, so that's fine. And for the weekly basis, it maps onto the same thing that we had earlier. The number of patients on Sunday and Monday are really large, and Tuesday, Wednesday, Thursday, and Friday are really less, and the highest peak we see is at Friday. So now let's take a look at the number of patients who had recovered. So let's make the forecast as of now. So the model has been trained for the last to make forecast to the 7 days. Now this is what it looks like. The forecast has been made, and this is what the graph looks like. So again, the number of people who have recovered correlates with the number of patients who had active cases in India. So as you can see, the number of patients with active cases increased, and the number of people who had recovered also increases as well. So as you can see, the number of recovery also seems to have a steady increase, and for the weekly basis, as you can see, many people have recovered during Monday and all that, and other days the recovery is not that much. And now finally, let's take a look at the number of deaths. I'll just run the same code, and to make sure that our data is up to date. So the the model has been made for the last 4 days. The forecast is being performed. This is a forecast. We take a look at the graph. This is what it looks like, and it looks that the number of recovered patients or the number of deaths is also increasing, but again, the increase is not that rapid. So as you can see, the number of deaths isn't that big. Every day 2 or 3 patients are dying apparently, so that's the increase. And the number of deaths is also slightly increasing, but it's not really something to be concerned about, since we look at the left hand side, and it's only in the range of 0 to 5, so it's not, at least not based on our data. And this is what the weekly breakdown looks like. So as you can see, machine learning can help us in various scenarios, at least in the data visualization and time series analysis method. You could dabble with a lot of different kinds of data to make use of the machine learning techniques that you can learn. Now let's move ahead. So whenever it comes to learning new things, whenever it comes to making sure that you are at the cutting edge of the technology, a quote that always helps me out is, an investment in knowledge always pays the best interest. So keeping that in mind, we have a community site on which you could log on, create your own accounts, and if you ever run into any issue which is technical or not even non-technical, you wish to get some information about some technology, maybe you written some code and you ran into some error, what you can do is you can post about your issues on the community site, and people who are your colleagues who have similar interests as you could help you out. Maybe they have faced this issue before, or it could be that a domain expert could take a look at the technology, the post that you have posted, and help you out to get the resolution of that error. It's a great community site. There are a lot of technologies being covered. There are a lot of people who are on the community site. The engagement is quite good, so you could take a look at that. We also have a blog, Intellipaat blog, in which we put out articles on different technologies, on how one technology compares to the other, and which one's best for the tool, or which tool is best for the job that you're trying to do. So take a look at the blog that we have as well. There's a lot of free content for you to explore and understand how to get started with certain technologies, and how to uh, uh, further your career in a certain field. And we have our own YouTube channel as well, as you can see. And you could just click subscribe and click on the bell icon to never miss another update. We put out a lot of free content, and that helps you out a lot, especially in these scenarios. But if what I have, the demos that I had performed, piqued your interest, and you want to have the powers that, or the understanding that I used to make these kind of predictions, we also have a data science course. It's one of our most highly ranked courses. It's got 42 hours of instructor-led training and 28 hours of self-paced videos. So there's a lot of content for you to go through. We teach it from beginner's perspective, so you get to, even if you don't know any programming, you could enroll into this course and learn a lot. There's exercises and project work to solidify your understanding and help make sure that you have something to show for when you complete this certification. You have flexible schedule, lifetime upgrade, and 24/7 support. There's a lot you could take a look at the course. There's a lot of information for you to go through. We teach you about data science and R and all that. And we teach you about Python as well. We teach you about artificial intelligence, support vector machine, different kinds of machine learning algorithms, data science technologies. We teach you about statistics, visualization, manipulation, exploration. We teach you about association rule mining. There are a lot of good content for you to go through. We have several projects as well, as you can see, and you can take a look at them as well. We have some video tutorials for you to take a look at. Here's a certificate. It's a sample certificate. You can imagine your name here. Certificates really help you out in these scenarios, mainly because if you have a certificate, then it allows you to stand out of the crowd. It gives you competitive edge, and many recruiters are looking at people who have a certificate so that they could further the interview process. So you can take a look at that as well. This certificate is accepted in many MNCs like Ericsson, Cisco, Cognizant, Sony, and there are many others. These are just a few. You can take a look at some of the reviews that we have had. It's one of our most well-reviewed courses. As you can see, people have had good things to say about our course. And now let's take a look at the other things. So we have our course advisors informations. We have, if you have any question, it's very likely that it's been mentioned in the FAQs. You can take a look at the FAQs, and this is what it looks like. These are all the questions that you may have and have been asked by other people as well. But in case you don't have your question listed in the FAQ section, don't worry about it. Let me just show you what you can do there. So let me just run this. Yeah. So if you don't have it, don't worry about it. I'll tell you how you can reach out to us. But the first thing that I'd like to share with you, since you stuck around with me till the end, you get a coupon code in which you could use to get 30% off on all the courses. This is YouTube 30. The coupon code is YouTube 30. You could use it uh, today, tonight, and use it immediately, and you get flat 30% off. This is only for the YouTube viewers. and it's only valid for today. So if you check out the courses and if you choose to buy it, do apply this course and get a flat 30% off. And now, if your question was not listed in the FAQ section, then you could contact us on these numbers that have been listed here. It's we have a number for India, we have a number for US as well. The number is toll free, and if you want to reach out via email, you can do that to us as well. And we have our course advisors waiting 24/7 to have a chat with you. They will help you to get the course that you need the most. And with that, thank you so much for sticking around with me. Hopefully this has been helpful to you, and hopefully this has helped you understand a few things, and this has helped you grasp a few important concepts and makes you ready to tackle different problems in the future. So thank you so much for joining me, and see you next time.